Recording in progress.
In this video, we'll talk about proteus, how to use proteus. So proteus is used to connect to perform some practicals. What you can do with proteus, you can design on projects and run them to know how is your project going to work before you connect it using a real component. So proteus is used to guide you whether you are wrong or right. Because if the circuit doesn't run on proteus, that means it will never run on breadboard or veriport. Your project will never run. So we need to use proteus to confirm whether our circuit is going to work or not. So in this blue square line, that's where we connect our circuit. If you connect your circuit outside this box, you cannot save it as a PDF. If you connect it outside the box, you cannot save it as a PDF. But if you connect your circuit inside this box, you will be able to save it as a PDF. So now let's see how do we use proteus and how do we connect. Here there's a zoom in, zoom out, and this is to go back a lot. But now I'm going to only show you on how to connect, not how to create a PCB. That one will be a tutorial for another day. Now let's see. Let's just know how to connect and how to use it for basic designing experiments or circuits. There's P and L letters, and it written devices next to them. So if you want components, you click on P. Therefore, it's going to show you this. Then underneath the keyword is space. So on this space, that's where we search our components. You have to know the name of the component or the code of your component. You can use both the name of your component or the code. Normally, when you use the name, you only write the first three letters of the name of that component. Then it will be shown here. So now let's search resistor. Resistor, first three letters of resistor is res. So I'll type res. Then here it will show me the component that is already picked and is resist. So to record it, I'll just need to click enter. Then my component, it will be shown underneath the P&L section, or you recorded a component underneath them. So that means that there's already a component that you've picked. You will be able to drag it and connect. So since I want to design a basic circuit with multiple resistors and an LED, so I'll need to pick a battery. A battery is a voltage source, something that will supply my circuit. So you always need a voltage source or a current source for a certain circuit. Depends, you want to use a signal source, a signal as a source or what. So now since it's just a basic circuit, I'll need to search for a battery. Again, click on P, then you type battery. Just write bat. Therefore, I scroll up. There's a battery here. A battery for multi-cell, single cell, can pick any battery. I'll go with multi-cell. So when the component, the picture of the component is shown here, that means the component is picked. So you can click enter. Once you click enter, it's going to be added here. Therefore, I'll need an LED. For LED, a practical LED, the LED that will show whether it's off or on, you need to also specify the color of your LED. So now it gives me a simple LED. This is a simple LED. It's a symbol of an LED. So it don't show me whether it's on or off. So I'll need to specify and add the color of the LED that I want. I'll type red. So here there's red LED, yellow, then I'll go with red. Click enter. Therefore, now I will have to connect. So if you want to take your component from this section inside the box, remember the inside the box is where we connect. You'll click on that component. Now I've clicked on the battery. You can see by this blue color. So that means my battery is recorded. So you don't press and hold on the mouse and go to the box. You just press once, then you press, you don't hold. From there, you go inside the box. You press twice. You'll click twice on the mouse or left click on the mouse of a computer. Left click twice, and the mouse of a laptop, you double click. So I'll double click, then the component will be placed inside the box. Now I've placed for a battery. Now I want to place a resistor. Again, you click on the resistor. Once you see the blue, just know your component is dragged. So now I'll need to put the resistor. If I want to put the component, if I want to see the component and move it, you only click once. I will click once, then the component is shown in this color. So since now if your component is shown in this color, just know the component is not yet placed. So you can move it and place it where you want it to be. So now since it's like this, that means I can move it because it's not yet placed. Then I want to connect it, I want to place it here. I'll have to click again. Then the component now is placed. I'll pick another resistor, it's already recorded, so I'll just need to double click or click once. So I will click again, then I'll move to that side. I'll have to align them, check whether I put it on the straight line for a beautiful circuit. So always make sure a circuit is neat. Therefore, I'll click again. So I'll need the last resistor. The last one I want to connect it in the middle. Click again. So since I want to connect in the middle, I can't connect it like this. I will have to change how it's placed. So I want to turn it vertical. You right click on the component. It will show you these options. So I want to rotate my resistor anti-clockwise or clockwise. So a resistor doesn't have a polarity. Anyhow, I can connect it. So I will just rotate it clockwise. So now it's rotated in the clockwise direction. Therefore, I will have to I will have to join my components. So how do we connect or how do we join components using Proteus? You double click, or if you're using a mouse, double click, it's left, double click. If you're using a laptop, you just double click on the mouse. You just double click on the mouse, then you move, you will see a wire. So now I will double click, then I move my hand. You see there's a wire there, it's moving. Then I want to connect this leg of the battery to the leg of the resistor. You will see by a red square. That red square tells you now join the wire to the other leg of your component. Then I will click again. Then now these two, they are connected together. Again, double click the red square. You will see a red square. Double click and move that wire to where you want it to be connected. Then I will go to that component and click. And now these two resistors are also connected. Now I want to join this resistor in the middle of these two resistors. So I will just double click on the wire and move it. Double click the wire to your resistor and click. Now the resistor is connected to this wire. Therefore, there's a dot there. That dot tells you it's a Y. Once you see a dot, it normally determines a connection. That means there's a connection, and we don't want this dot. So you right click and go to delete object. Now it's deleted. So usually you can't run an incomplete circuit on Proteus. If your circuit is incomplete, the Proteus won't allow you to run it. So you'll have to do a fault finding, and you'll need to know how to do fault finding. Now I want to connect the other leg of the battery to the middle resistor. Double click. I will go down a little bit. Therefore, if now you want to if now you want to make you want to turn, like you are moving a wire, then you want to bend your wire, so you need to double click again. Double click, then now my wire is bent. And I'll need to bend it again. Double click and I'll go up. And that's how we use Proteus to connect. That's how we drag the wires and join components. If you want to bend a wire while you're moving it, double click, then the wire will be bent. Therefore, you will be able to connect to where you want it to be connected. Now, at the end, I want to put an LED. You go on your LED, you click. Once you see this blue, that means it's recorded. Then come inside the box. You click once. It shows you there's a component that you needed to connect. So now, since it's still in this color, it's not permanently inside the box. So if I want it to be permanent inside the box, I'll need to click again. So if I click, now the component is placed inside the box. Therefore, I'll need to join my components. For the resistor number 2 and the LED, on the leg of the resistor, where is the Y or where is the point? You see by a red square, a small red square. So I will double click and drag to the other leg of my LED. Then I'll come to this junction, double click. Remember, I can't make this wire diagonal to the LED. I want my circuit to be neat. So I'll go, and then once I get here, I will have to double click so that the wire will be bended. So double click, then you will see a small star. So that small star tells you your wire is being bended. Now you can move it. Then I'll move it to my LED. Then now my LED is connected with the other component. So now my circuit is complete, but I'm not done. I'll have to change the values because the resistor always they come with 10 ohm amount. So you need to change it to the amount that your circuit, the amount that you need to use on your circuit diagram. Remember, if you're designing, you will have a certain amount that you need to use for your resistor, not just any amount, so that you'll get the results that you're looking for. I can't just use 10 ohm while the circuit says use 5 ohm. So I will be getting different results. So for me to get the result that I'm looking for, or the correct ones, use the exact values of your components. So now I want to change. How do you change the amount of a component or the value of the component. Now I want to change this resistor from 10k ohm to 390 ohm. You go to the value of that resistor or the amount of that resistor, you double click, then it's going to take you here. That's where we change the values of our components. I want the resistor to be 390. I'll just type 390, then press enter. Usually we don't put units. You don't put units on common components like resistors, but on the battery it comes with units. But then when you change the amount, even if you don't put unit, the proteus knows it's a battery, so the unit is volts. Now I want to change the resistor number 3. Again, double click. Is 220 ohm. Resistor number 2, double click. It's 100 ohm. Done. Therefore, my voltage is 12. Then enter. I don't put the unit. Proteus knows it's a battery, so the battery value has the voltage, and the voltage is measured in volts. So it's not necessary to put the unit. But normally, when you're creating a circuit diagram that you will use on your report, you will need to put the units to specify. When you want to save your circuit, and that circuit will use it on your report, or when you're going to present, you'll need to put the unit, specify, so that they won't penalize you. So now the circuit is complete. So let's run it. See, we are not able, so the circuit now it can run. The LED can glow. You can see, you run the circuit here. Okay, when you want to run the circuit, you want to stop, want to hold it, and then that's where we run the circuit. When now it's green, that means the circuit is running. Then now when I press the square button now, see it's the LED goes off. Sometimes the circuit won't run. So you always need to put a ground. Sometimes the circuit will never run when you connect it. So this one runs because I'm using a battery as a source. A battery has negative and positive. So that's why it's able to run. But sometimes some of the circuit you'll need to connect a ground in order for that circuit to run. You'll need to put a ground. So where do we find ground? You come on these yellow lines. There's yellow boxes there with points. You click on them, then already ground is recorded. So just come on my circuit, click. You can see there's a lines there. They form a triangle. So that is ground. That component is called ground. Then ground, you connect it on the negative side of your component. Remember, some components, they are polarized, some they are not. So polarized component, it means the component has the negative side and the positive side. So if the component is not polarized, that means your component doesn't have a positive side and negative. You can use any side as positive or or negative. So you need to know where is your negative of your LED and your battery. So now on this circuit, my negative side is on the bottom. The bottom side is negative and the top side is positive. Why? It's because you can see the battery. The battery, the small line at the end determines negative, and the big lines at the end determines a positive. So I will put my ground on that junction. Now it's connected. How do you know on LED the side is positive and negative? The negative side is where the triangle point. Where the triangle point is going to be a negative side. which is called cathode. Then where then at the back of the triangle, or what is not a point of the triangle, is called anode. So this side is anode and this side is cathode. Anode positive, cathode is negative. Then I will run my circuit again. See, still fine. So this ground, you'll always need to put it. Sometimes some of the circuit they won't run because of this. If it didn't connect ground, your circuit will never run. Therefore, now let's see the benefit of proteus. I'm given this circuit as a homework. They said go and calculate the voltage and current of an LED, of the LED. And then I don't know how to calculate, or I did calculate, but I'm not sure of my answers. So if you're not sure of your answers, proteus will give you the correct answers. So actually, you can use proteus to guide you when you have a complex circuit where you were asked to calculate voltage and current. If you're not sure of your answers, you can use a proteus. How? Let's see how. You go. There's something like a pen there. Underneath that, you can see that yellow symbol. There's a pen. Is a pen and there's a Y. Underneath, there's that thing looks like a gauger. The thing that looks like a gauger, it returns virtual instruments mode. So you click on the virtual instrument modes, then there's a AC voltmeter, DC voltmeter, signal generator, oscilloscope, logic analyzer, what. So now on this circuit, I'm using a DC voltage. Since I'm using DC voltage, that means I'll use DC ammeter and DC voltmeter. Since I want to measure the voltage across my R2 and my LED, I will click on my DC voltmeter. It's the same, the way we place it is the same the way we place your components. Then I'll come close to my LED. Before you place your components, you'll need to stop your circuit. Now my circuit is running. I want to place this voltmeter. You hear the sound. The sound tells you your circuit. If there's something that's happening, and then you want to do something on what is happening. So you can't do a fault finding while the circuit is running. So that one is for safety. You cannot keep the component while you are supplying a circuit. So you might get shocked. I will stop my simulation and then now connect my DC voltmeter. See, the DC voltmeter is a positive symbol and the negative symbol. So I will just connect it as it is because it's placed well to the positives and the negatives of my LED. Now the question said find the voltage and find the voltage of your LED and the voltage of your R2. R2 which is the 100 ohm. Again, like this. So now I want to change, or I want to put my DC voltmeter horizontally. Right click, I'll just turn it anyhow, then I will change it, or to put it I will change it when I want it to be in a polarized form. When I say polarized form, that means negative to negative, positive to positive. Then I'll just turn it anyhow. Now check, I've turned it in clockwise, and if I want to connect it to my circuit, the positive side must come in the in on the right, I mean on the left, and the negative side must go in the right. So now I want to change, or I want to swap my positive and negative so that it will be placed well. So you right click, you go to X mirror. X mirror, you can swap the legs of your component horizontally. Then Y mirror, you can swap the legs of a component vertically. When I say vertical, that means if you have the head of your component on top and the tail on the bottom, and now you want to swap the tail and the head, you will use a Y mirror to swap them. So now I will use X mirror because it's placed horizontally. Look, now the positive and the negative of my voltmeter, they are swapped. Then I will connect it to the resistor. Remember, when you measure the voltage of a component, or how do you measure voltage? A voltage is measured across a component. That means you just go straight to the component. You put the probes of your multimeter or a voltmeter. You will be able to measure that voltage. I will run it. Then now look, it gives me the voltage of the LED and the voltage of the 100 ohm. The voltage of the 100 ohm is 0.87 volts and the voltage of the LED is 2.2 volts. Then if I was asked to calculate the voltages of R2 and the LED, and I'm not sure with my answers, then you just need to use proteus to confirm whether you are wrong or right. The proteus will never go wrong if your connection is fine. But once your connection is wrong with the circuit, or once the connection doesn't correspond with the circuit connection, then it will give you different values. So always check the connection of a circuit, how the components are connected, whether they're connected parallel or series. Then put it as it is the circuit on proteus. Then it will give you the correct values. So now that's how we measure a voltage using proteus. Let's measure the current. How do you measure a current? Current, I'm going to take a DC ammeter. A DC ammeter is a multimeter that is not a multimeter. A DC ammeter is a component that is used to measure a DC current on a circuit. When I say multimeter can measure both current and the voltage. So ammeter, DC ammeter, like specify or this component can only measure this. So ammeter, that means can only measure a current. So I want to know the current that is flowing in R2 and LED. So when you measure a current, you see, I forget to stop my simulation. Always stop the simulation. When you want to measure a current, you will need to open circuit. So a current is the one that is flowing. So if I want to know the current that is flowing, I will need to break or open circuit and then put the ammeter or the multimeter, then complete the circuit. That's how we measure a current. You need to open circuit and put it inside. It must also current flow inside that thing. So the current must flow inside the ammeter so that it will be able to read. Measuring measuring a current and voltage is not the same. When you measure a current, you need to do an open circuit, then complete that circuit using that component that you're using to measure a current for your circuit. So I'll need to open circuit. So there's a space here. Open circuit, I'll cut. Right click, delete the wire. I've deleted the wire. My ammeter is placed well. Since the positive is on the top, so obvious it must be. So this one is positive and negative. So always the current enters at negative, at positive, and leaves at negative. So the current enters at higher potential and leaves at lower potential. So what is a high potential? A high potential is a positive and low potential is negative. So I'll connect to that junction of the resistor 1 and resistor 3, and the negative side to R2 and LED. So you see how I placed this DC ammeter. The way I placed it is going on is going to, the current now will flow in it and then to R2 and LED one. So that will read the current that is flowing in R2 and LED one. So it will tell me what's the current that is flowing in R2 and LED one. If you want to know the current, you need to open circuit and then connect your ammeter to complete that circuit. So now I use this ammeter to complete the circuit because I've removed that wire and now it's working as that wire. The wire that I've just removed. Now I've connected the ammeter. Now it's working as the wire. Now it's completing the circuit as that wire was completing the circuit before. Therefore, I'll need to run my circuit. If now, see, I forgot to click, then you'll see there's dots. The dots tells you there's a connection. There's a combination of two wires. These dots, these dots tells you there's a combination of two wires or more. Once there's a combination or there's a junction or you connected two wires or more, you will see by these dots. You will see by these dots. Therefore, I will run. I've run my circuit. So it says the current is 0, 0 and the voltage is still the same. I will stop my circuit. Stop. And I will change the units. I will change the units. I want to change the units. Now it's written in amperes. I will change them to microamperes. Remember, on this circuit, I assume the current is very small. So I will change it to microamperes. Since it's microamperes, and then I've put it amperes. Amperes is like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 amperes. So once I use microamperes, milliamperes, it's an engineering notation that is used to, like, micro. That means current is very, 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 very small. It's times 10 to the power -6. So if I have 5 microamperes, it's 5 times 10 to the power -6 ampere. So that means your current is very small. So on the proteus, if your current is very small, and now on my ammeter I put it amperes, while the current is in microamperes, so it will give me 0, 0 because the current doesn't match my units of my meter. Meter, that means the thing that I'm using to measure. Now let's run it. It says max. Now it says max. So when you say max, that means my current is in milliamperes. Remember, I'm just assuming the current. I'm just assuming the value of the current. So let's see how much is the current in 10 seconds. So that means I will have to put milliamperes. Okay, you see we have microamperes, milliamperes, amperes, kiloamperes. Kiloamperes is a number times 10 to the power 3. Number times 10 to the power 3. I think you all know the integer notation stuff. So let's use milliamperes, enter. Okay, so let's run and see how much current is flowing. You see, now it's 8.74 milliamperes that is flowing in R2 and LD, in our LED. So using proteus, for me, proteus, it's a nice thing. Like it's a cool and simple software because you can design things that are impossible, but proteus will make them possible. Then when you connect those things in like practical or in real life, you will see something else. Just know it's a proteus, so you can't trust it 100%. But when it comes for values, it's 100%. But when it comes for design, some designs, uh, whereby it won't take the problem about the proteus, it will never tell you that the voltage is too much for the component that you're supplying. That's the problem. If you're supplying 500 volts on a resistor or an LED, it's the will be banned. Then it's going to replace it 1,000 times. So you'll never see, or your component is being damaged. You'll only see in when you connect it like in real life or normal. This component is being damaged is because Proteus won't tell you the voltage is too much for your component. So you need to use the engineering mindset. You can supply, you need to know the maximum voltages of your component before you supply. Remember, components has minimum voltage and maximum voltage. So once you exceed the amount of the voltage, that means you might damage your component. Therefore, that's how we use Proteus and that's how we connect. So now, let's see how we save a circuit. Let's see how we save our circuit as a PDF format. I will stop my circuit. I'll leave these ammeters and, or let me just run it. I'll need to see the values. I'm not sure whether we'll be able to see them once it's saved as a PDF. You click on File, then Export Graphics. Go to Export Graphics, and then it will show you some options there. Then Export Adobe PDF file. Click on it, and then press Enter. Okay. Then let it load. Now it's loading. It's loading. It's loading. Let's cancel this. It's loading. Now here is the circuit. Here is the circuit. Here is the circuit. Here is our circuit. Is in a PDF format. Is saved. It took it the way it is from the Proteus. Now we put it in a PDF format. Now is a paper. You can print it out and click add, like attach it on your report when you're going to present, or you can copy it, or you can convert this into a Word format and copy it, paste it in a report when you are typing, while you are typing your report on the Word app. So sometimes they will ask you to draw the circuit and you can't draw it, but they say don't draw it by pencil. So to draw it uses Proteus. You draw, save it as a PDF format, change that format to Word, then you copy it, then you paste it in your report, then you print it, then your report value look neat. So that's how we save using Proteus. That's how we save using a Proteus.